So the best part about the lesson today is that you already know how to do it. Okay? You remember back at the beginning of the year when we talked about all the different parent functions we talk about this year? Linear, quadratic, cubic. Oh, cubic. It's time for cubic. Okay? Now, we've talked about other stuff between then and now. We've talked about the square root function. Talked about that kind of opposite of the squared function, the quadratic, because those are inverses. Remember I was talking about that? Little, tiny bit? Okay. We talked about some exponential functions. We'll talk more about that coming up soon. We'll talk about logarithmic functions coming up soon, rational functions. I mean, there's a lot to look forward to this semester. Okay? But today we're going to talk about cubic functions. Okay? Now, I wrote this on purpose, but kind of as a joke, but kind of to be serious. You do remember that those are the same things, right? For Algebra 2. You know later on, in way higher math, then y and f of x are not exactly equal, but for us, they're the same, right? Okay, just making sure. So, typically when we get to a very new parent function, do you remember what we do? We usually graph them and talk about their transformations. Ooh, transformations, okay? So, here's the first two that we're going to talk about, first two problems. What kind of transformations do these two functions, in general, not specific, what kind of transformations do these two functions make from the parent function? Horizontal. And how do you know that? Because they're inside. Okay? So these are horizontal. Right? So that implies that we're going to be moving which directions? Left and right. Okay? Now this is inside, so that's how we know it's horizontal, because it's inside the function. Okay? So which one goes which way? So this moves left 4. So it is a horizontal shift. And what's the most important letter in that word? The F. Okay, remember the F. If we forget the F, it's bad. That's bad. Okay. What about this one? How about if I not put 2 T's in the word right? Are you okay with that? Right 2, and is also a horizontal shift. Okay. Does that seem backwards? I know we've had this conversation before, but we're going to have it again. Does it seem backwards that it's plus 4 and we're moving to the left? Yes? So how do you make that work in your brain? Just because. Okay? All right, I'm okay with that. What about these two? What kind of a vertical what? Shift. I'm going to go ahead and write horizontal shift right here and vertical shift right there. Okay? So which one goes which way? Top one goes up. So I'm going to write this in the correct order. Last time I didn't write it in the correct order right there. So what am I going to write here? Vertical shift. You said up. And then this one is vertical shift down 5. Is that backwards? Oh no, so that's okay. If it's plus, it moves up. If it's minus, it moves down. That's like what we think it should be, right? Okay. What about this? Reflections. Yay for reflections. Except for mine, first thing in the morning. Scary. Okay. Which one goes which direction? So it's a reflection over the x. How do you know that? It's outside of the function, and we already decided that things that were outside of the function are vertical changes, And for it to go vertically, it's this way, so it's got to reflect over the axis that's here because it's going this way. Yes? Guys, am I telling you anything new? No, this is all stuff we've already done. We're just making sure we're together. Okay? What about this one? This one's over the y-axis. Why is it over the y-axis? Because it's inside. We know things that are inside are horizontal changes. For it to be a horizontal change, it's got to go this way, so it's got to reflect over that y-axis. Okay? All right, what about this one? Or these two? What kind of shrinks and compressions? Why are they vertical shrinks and compressions? Good. They're outside of the function. Vertical? Oh, yeah, they are. Shrink or stretch. We could say compression or stretch. I had already written shrink. Sorry. But not really. Okay? All right, so what goes what way? Top one's a stretch. So we say vertical stretch. Very good. By a factor of 2. What about this one? No. Where is it? It's on the outside, so we're still talking about vertical. Vertical. Do you want to say shrink or compression? Either one. Don't care. I heard this word first, so I'll write that word first. Okay? Vertical shrink by factor of 1/4. Okay, what's left? Horizontal shrink or stretch? Oh. Which one's which? Horizontal shrink for the top one? Again, so things like up here, it's opposite of what you would think. Because it's horizontal, same kind of deal. It's opposite of what you think. You see the 2 and think that's going to stretch it because it's a number greater than 1. But it's not. It's going to be a horizontal shrink by a factor of 2. Which means this one's going to be a of 1/4, right? Okay. Can you go backwards? What if I tell you, oh, do you have that? Sorry. All right. What if I tell you that it goes up 4, left 3, and it reflects over the y-axis, but you have to start from here. Not from the parent, but from here. Can you do that? Okay, so we have our original function, f of x equals x to the 3rd plus 5. Why is it x to the 3rd? Because we're working with cubics, okay? So what makes it go up 4? So I add 4 right here, right? What makes it go left 3? So instead of just x, I have to write x. It's going left 3, so plus 3 cubed. And then what makes it reflect over the y-axis? Negative. It's a y-axis, so y-axis goes this way. So it's inside, right? So our final equation then is negative x plus 3 cubed plus 9. Any questions about that? Have a good day.